get rid of this one. I'm going to close the poll, and hopefully you are now seeing my screen that reads Advanced Analytics. Again, my name is Mario Sanchez. I run training here at Sumo Logic. A little bit of housekeeping. I will, as you've noticed, you are all on mute, so you cannot ask questions verbally. However, you have a GoToWebinar panel on your right-hand side. Any questions that you have, feel free to shoot them through the webinar, through the panel. And as much as I can, I'll keep an eye on that panel. But if not, we'll certainly have time at the end for questions and answers that we can go over all those sessions. All right, so let's get started. At the completion of this webinar, as far as the agenda goes, I want you to, since we have a couple of newbies on the call, I want you to make sure that you understand the anatomy of a query. And then we're going to jump into slightly more advanced operators, operators like Outlier, operators like join, LogReduce, LogCompare, transaction, geolookup. I know there's a few newbies on the call. I'm also going to point you to some other operators, but for the benefit of the ones who do know how to run queries, that we're going to focus on these slightly more advanced operators as well. I'm going to talk a little bit about Livetail and how you can look at your live logs even if you don't have access to your production environment. And then, as I promised, we're going to explore the query library in our community, which is called Sumo Dojo, so you can know where to go find more of this stuff. Starting with a 30,000-foot view, the Sumo Logic data flow is broken into three main areas, if you will. Getting data from your source systems. We do that data collection through collectors and sources, and we're not going to spend any time in here today. We're assuming that your administrators already got the data into the system. Where we're going to be spending time is in this number two, how to analyze, how to start searching and analyzing your data. What are the operators out there that are very meaningful for me to start using my data, and how to create some charts out of that. We will not be talking about how to create alerts, how to create dashboards, but similar to this webinar, we've run multiple webinars specifically on alerts or webinars specifically on dashboards, which I would encourage you guys to take a look. And if you're wondering where you can find those, let me just open a new tab in here. There is a page called sumologic.com/training. And in that page, if you scroll down a little bit, you'll see that there's public instructor-led courses like the one that you're currently on. You can attend, you can have us come out and run private customized training for you. Or in the online self-page, if you click in here, there's a little bit of some shorter videos, 2-minute videos on how to start getting your data into the system, how to use some operators. But down here at the bottom, there's a library of many of these webinars that we've run in the past. For example, how do I monitor and alert my data? So these are webinars that we've run in the past specifically on those areas. All right, going back to our to this, we're going to be spending most of our time here in the Sumo in the search and analyze part of the data flow. So why queries? Why do we want to run queries? Well, queries are going to allow you to troubleshoot and identify your trends. Also, queries are the building blocks for your dashboards. Every dashboard has a panel. Every panel in a dashboard has a query behind it that allows you to monitor and visualize your data. And similarly, behind alerts, there are actually queries that allow you to notify you of critical events, identify those critical events, and notify you about them. But here's the deal, and especially for the ones that are brand new to Sumo Logic or newbies on this call, you do not need to start from scratch. Actually, Sumo Logic has a lot of apps out there that is out-of-the-box content for the popular sources that you can take advantage of. And the cool thing about that is it has a whole bunch of pre-built queries. Let me give you an example. I'm going to go over here to my environment. Let me close this tab here. As many of you already know, this is what your search screen looks like. If you go here under Library and you scroll down to Apps, you will notice that there's tons of apps here that already have pre-configured content. For example, we know what Apache logs look like, and we have a very good idea what kind of things you would want to know about Apache. You would want to know about your server errors and your client errors. You would want to know about latencies and that kind of stuff. So we've put together here a whole bunch of dashboards and queries which we think are going to be very beneficial to you, which you can easily install, and then without having to configure anything, all that data would appear. Earlier today, I actually did exactly that. I installed it, and I went here and installed it under this folder called Apache Apps. And you'll notice that's the exact same list of queries and dashboards. And I opened a few of these so that I can show you. Again, I've done absolutely no configuration. All I did is I pointed this to my Apache data. And look at this. This is actually my data showing me my visitor locations. It's showing me traffic distribution by server, responses over time, my traffic volume as well. And this is just a sample. There's about 6 or so of these dashboards that get built for me. And I had to do absolutely nothing other than tell it where my Apache data was sitting. The great news about all this stuff is that each and every one of these panels actually has a query behind it. So if you click on any one of those panels, for example, I'm going to click on that one, it opens up the query that sits behind that panel. So why do you care about that? Well, the good news for most of you is that this query, now you can see exactly how that query was put together. If you notice this, it's going against my Apache Access data, it's parsing my statement to identify my status codes, and then it's looking only for those status codes that match a 500 or 501, 502, 503, whatever the case might be. And that's how I can identify what my client-side errors happen to be. There's a little bit of additional formatting that it's doing down here. But the good news to you is that this is now a great template that you can use going forward for your other queries. For example, if you really cared for your server-side errors, you just have to change that into 400. And there you go. You've now created yourself a brand new query that you can run, you can save, and save as something else if you want to. And now you know how to find other types of errors as well. So again, good news for you is that there's a lot of apps out there that get you started. I think I have even some examples of the Artifactory app in here as well, and how I can see some of that data out there. All right, I'm going to close some of these. Again, if you have any questions, feel free to use the chat to send some of those questions over. Let me go back in here. I think I even had some screenshots of, for those of you who are AWS based, this is a screenshot of the app that comes out of the box for AWS CloudTrail, showing me operations, requested AWS services over time, events by your AWS regions, created resources over time, and so on. And I have another one here for AWS VPC flow logs. So it's showing me data about my source address locations, rejections per minute, and you get the point. The ability to get all this content out of the box. And the good news is sometimes I don't even know exactly what kind of data I need to get from VPC Flow, but this is a very good start. It might not get me 100% there, but it sure gets me 80, if not 90% of the way. And then I just need to customize that 10% that is particular to my organization. All right, so for those that are brand spanking new to Sumo Logic, let me quickly cover the basics of searching. What does the anatomy of a query look like? So if I were to go in here, most of you have seen this screen before. And what am I seeing here? This is my search bar where I can enter my queries. This is my time range in here. And when I run a query, I get some histogram down at the bottom that is showing me just counts number of messages per minute or per 2 minutes, depending on what my time range happens to be. And what I see down here at the bottom are my results. In this particular case, because there is some sort of an aggregation with a count, it's showing me some aggregates, but I could also see the messages themselves, the raw messages that make up this particular, that got filtered down by this particular query. When I look at the aggregates, I have the ability to look at a table itself with all the messages, or I can look at the results in some sort of a chart as you were seeing before in this particular case. So that gives you the big picture in terms of the UI itself, and which is what these ones are doing. But from a search perspective, what a search normally does is you first filter your query with your metadata and your keywords. And by metadata, I mean where the data is coming from. If you notice on my query in here, I'm saying I want this data to be coming from my source category equals Apache Access. That's my metadata. I also could specify keywords. If I know in particular that I care only for 404s, I can say and 404. Or if I really know that my messages are going to have the word error in it, I can add keywords to even further filter my data as well. Then I want to normalize that data. I can use some sort of parsing to start normalizing my data. And you notice in here, I am parsing for a status code, which then I do additional filtering for that which is this in here. I can filter by using the where clause. I can filter like is null or is blank or is empty. And once I have done these ones, this is where the fun begins. I can start using any kind of aggregation. I can do sorting, counting, summing, average, and all that good stuff. This is where I'm going to be spending most of the time today, how to aggregate and how to get some very useful operators for aggregation of that of your data. All right, so again, the structure of the data is you have some metadata tags, you have some keywords, you then do some sort of parsing, you filter that data. I'm going to send these slides to everybody attending this session because I'm not going to go into detail on the basics of this kind of stuff. I want to jump into the more advanced ones, but this explains what your metadata fields look like. This explains what kind of keyword searches you can do. And it also talks about a little bit of good habits around searching. Same thing with your time selection. You can select from the drop-down, you can do relative notation, you can do absolute notation. Again, I'm going to skip a lot of this because this is more of the basics for another webinar. You can parse your data, and these are the different parse operators that you can use. Again, you can explore this on your own, and there's a little bit of good habits around parsing as well. All right, but what I want to get to is some query examples of the more advanced operators that we talked about today. So the first thing that I'm going to do is I'm going to point you to documentation. Why? Because there's a lot of great information in there. And you'll notice I'll point you to documentation a lot. I'll point you to community, our Sumo Dojo community as well. And as a matter of fact, I think that today what we're going to be doing is we're going to be running most of our training off of the documentation. So the first thing that I want to show you, and by the way, documentation is found under help.sumologic.com, or if you're in your environment, you just go to help and click on documentation. And once you're there, what I would suggest is search for operator cheat sheet. This page in particular, it's going to give you a very good high-level view of all the different operators that are available in Sumo Logic. So it's a big list. You see me scrolling down, and it's quite a big list. But the good news is that it's broken by the function that it does. So these are all my operators that are good for aggregating. As you can expect, I can do things by average. I can count. I can do mins and maxes, percentages, and all that good stuff. What if I wanted to do some parsing? Here's my operators for parsing. If you're sending me, for example, CSV files, we know how to parse that. There's an operator called CSV. If you're sending me key value pairs, meaning name equals Mario, company equals Sumo Logic, we know how to parse that. If you're sending us JSON files, we know how to parse that as well. What if you're sending us things that are not that well structured? Well, we can use parse regex for something like that, and you can knock yourself silly looking for patterns and parsing using regex. Okay, that's the good news. But what I wanted to talk about today is perhaps the most obvious operators when you do a search are the ones, let's say that I just search for the word error. Not the best of searches, because in this particular case, I asked Sumo Logic to go across my entire data set and find out where the word error exists. Not the best of searches, but for the purpose of this session, it's not that bad. I looked at all my errors along the last 15 minutes across my entire session. So the first two operators I want to talk about are these ones that are jumping out from the screen, right in the middle of the screen, LogReduce and LogCompare. These guys are pretty cool. Here's what they do. I'm going to kick off LogReduce here in a second and show you. Notice how I searched for the word error and I got 44 pages worth of errors. When I click LogReduce, I'm actually asking Sumo Logic to use its machine learning algorithms to go through all those messages that I had initially identified and figure out which of those messages are so similar one to the other. So if you remember, here are my messages, and now if I run this LogReduce, it created a new tab called Signature, and what it did is it said, wow, this message looks so similar to this other message. So what I'm going to do is I'm going to create a signature. And yeah, of course, there are some things along this message that are not the same. For example, the date. The date happens to vary from message to message. But there were 303 messages that all said database connection error, cannot connect to local MySQL server through socket, so and so and so and so. So what it's doing is it's reducing that noise. It's helping me identify, or it's helping me go through potentially thousands of messages and reducing them down to just tens of messages, or maybe even just a handful of messages that all of a sudden now it's easier for me to look through. This sounds like a cliche, but what this does is it allows you to look for that needle in the haystack when you don't even know what that needle looks like. So now all of a sudden, I know that I don't have to worry about this one. There's 300 messages of that. There's another 200 messages for this. And I can start looking at the things that happen even less. Like in this particular case, there's only 71 messages that look like this. This data that I'm looking at is very repetitive. It's just a training instance, so not that meaningful. But you can imagine how if, for example, someone had made a change on a firewall port or something like that, that would be the one unique message that is showing up down here in my count, and I could easily identify that and find out what my message is without having to read through all these other error messages that I'm showing in here. So this gives you a good idea of how to use LogReduce. Let me give you a better example. What if I were to look for my data whose source category is equal to snort? So snort happens to be network intrusion detection and prevention data. So this is a system that gives you intrusion and detection prevention. If I look at my snort data, I could be having all these different messages that talk about intrusion. I can run a LogReduce on that and again, do the same thing. Bring down the number of messages that I have to rake through, because all of a sudden now I'm seeing a much smaller subset. I can see that I'm getting an attempt of information leak on a continuous basis, but now I don't have to read through every single message. I can see exactly which one it is. I notice that I have page 2 of 2, so maybe I just do a count and go down to the messages that are happening only once. In this case, it looks like I'm getting a web attack from a specific IP address. Perhaps this is what I want to do. I want to go find out what this message looks like. So I can click on that. Oops, it looks like I'm using maximum of my tabs. So let me just close a couple of tabs in here to make this simple for me. But what I can do is I can click on that message, and it's going to take me now to look at a query that has that particular message. I can see the details. I can see the IP addresses. Perhaps what I want to do now is find out what was happening a minute before that message and a minute after that message. So I can click on this and say, great, show me surrounding messages a minute before and a minute after, or 5 minutes before, 5 minutes after. Excuse me. So what I'm showing you here is the ability to start seeing, or troubleshooting your data by using this signatures algorithm that brings down the amount of messages that you were looking at before and bringing them down to a very small number. All right, so now what you're seeing me do here is I've got highlighted in here in light blue the message itself, and I can start looking at all the messages of what happened right before and what happened right after that message. If you notice, this pink triangle is showing me where my message is situated, but I have this many messages right before and this many messages a minute after that I can start sifting through. Or if I really wanted to, I can click LogReduce on it again and reduce the number of messages that I'm seeing for that 1 minute or 2 minute time period. All right, excellent. Let's move on to the next one. I'm not seeing any questions, so I'm assuming this is making sense for everybody on the phone. So let me just close a couple of tabs. All right, similar to that LogReduce, which I just showed you, I'm trying to close a couple of tabs here just to make it a little easier on me. Similar to that LogReduce that I just ran for you, let's do this exact same thing, but in this case, I'm going to do it with LogCompare. And what does LogCompare do? LogCompare does the exact same thing, or is hand in hand with LogReduce, except that I can now compare it to a different time period. Let's say that I run LogReduce with a 24-hour time frame. What I just told Sumo to do is I said, okay, go and find all the signatures that have the word error for the last 15 minutes, and now time shift 24 hours back and run that same 15-minute period, but 24 hours ago, and compare it to the time period now. And what this does is it comes back with this information. It's saying, you remember that database connection error you were getting? Well, now you're getting it 6.1% more than you did 24 hours ago. And that message that said child spawned but unable to open database link, you're getting that message 5.5% less. So this is just a great way for you to start identifying your changes over time of the different signatures that you guys have had. You can think of this as, what if you just pushed new code and you want to find out if you squash that bug? So you can compare the code that you pushed out now versus the code that you had 24 hours ago, and find out if something has reduced or is gone completely. How do you find out if things are new or they're gone? Let's see if I have any examples in here of that kind of data. Let's see. It doesn't look like I have any new ones. But if I did, what I can do, and by the way, I'm going to start showing you some good best practices. We usually like to start a new operator on a new line. I can do something like where, let's use first delta percentage is greater than, let's say that I want to filter to only those who have a percentage greater than 14. I can do exactly that. And now I'm going to see only those signatures where the delta percentage is greater than 14. And there you go. Here's that one that has a delta percentage greater than 14. Similarly, I could have done something like where, and in my case, I don't have any, so it's going to come up empty. But if you have any new, signatures that did not appear 24 hours ago, they would show up like this. Or if I have some signatures that are now gone that were there before, I can do something like this as well. Okay, actually, that's not the syntax. I think it is gone. All right, but that gives you a very good idea around LogCompare and LogReduce. Great. By the way, I promised that I was going to be pointing you to documentation a lot, so I could always go in here and search for LogCompare, and I should be able to find it mentioned in there. There you go. So this talks about LogCompare. You can click on the name and it gives you a little more information about LogCompare. There's even a video introducing or showing you exactly how LogCompare has been used. So always great to look at the documentation as well. And the same thing for LogReduce. It shows you the syntax, and you can click on LogReduce, and it shows you, it talks about LogReduce and how to use the operator, how to detect patterns, and also a video of how LogReduce is used itself. All right, the other one I want to talk about is Outlier. Let me just do a quick search for Outlier here. Outlier is a fantastic operator that when you have a series that has been timestamped, you are able to detect what things are out of the normal using this outlier operator. Here's the syntax for an example, but let me just go to that page and show you a little bit of what Outlier does. Outlier, using that syntax, allows you to create a graph like this that is showing you the actual data points that are showing up in your data, but it's also showing you the standard deviation and whether you are outside of that standard deviation. And if you are, it marks it with, in the graph, it marks it with a pink triangle, but you also get data or a flag in your data that you can use for alerting, for example. So let me show you a very good example of how to use Outlier that I've cooked up here earlier today. Let me pull this up and show you a great example of Outlier. So again, using best practices, here's my metadata. I'm looking at my Apache Access data, my web server data, and I'm doing additional filtering. I'm saying status code equals 200 and status code equals 404. Some of you will be wondering, well, how can he start searching for status code if, how is that field available to be able to search? This is conversation for another webinar, but I'm going to quickly cover it here just so that people understand how I did this. One of the things that you can do is you can build field extraction rules. And instead of having my parse statements be right here in my query, I can build a field extraction rule that allows me to parse that data as the data is being ingested. So I happen to have one here for Apache Access. And let me go edit it just to show you what it's doing. What it says is, anytime you ingest data that matches this scope, source category equals Apache Access, I want you to apply this parsing expression, meaning go search for this pattern, which looks like a number between 1 and 3 digits, followed by a period, and a number followed by 3 digits and a period, and you get the point, right? This is an IP address pattern. If you find that pattern, store it under source IP. And then if you find this other pattern, store it under method, URL, status code, and you get the point. I'm parsing out these fields. Therefore, since I do this at time of ingest, those fields are available for me to be able to use right away. So going back to my search, I can say, I want to find out from my Apache Access data only those messages that have a status code of 200 and 400. I especially like this query because it's going to show you quite a few different operators in here. All right, let me show you the result first. This is what I'm going to do. I'm going to run this query, show you the results, and then we're going to go back and figure out how we built those results. So here's the results. I'm getting not only a count of my successes and a count of fails, but I'm getting what I'm calling a failure rate, which if you know your math, you probably can imagine that this is equal to my fail count divided by my success count. But on top of that, I'm using an operator called Outlier that builds an upper limit, a lower limit. It builds the violation when I'm outside of it, and it builds a mean, it builds a standard deviation. So it builds all that stuff for me to the point that I can do something like this. And it doesn't look that great. Let's fix this a little bit so it looks a little bit better. Looks like it's going failure rate from 0.5. The good news is that you have the ability to change axes and all that good stuff. So let's go from like 0.03 to 0.1, and let's see what that looks like. Click on save. There you go. So this is what my my graph ends up looking like. I'm identifying those things that are outliers. All right, now that you know the end result, let's go back and figure out how I put this together. So again, I'm only looking for Apache Access data, and I'm looking only for those that are 200s and 404s. Then I'm time slicing the data so that I can see it over time. As you see in this graph, I'm seeing this breakdown over time because I use the time slice operator for that. I take it a step further and say, okay, if my status code matches a 200, then create a new flag or a new field or a new variable called successes that's going to have a whole bunch of ones and zeros. So successes has a 1 if it's 200 or a 0 if not. And I do the exact same thing for a new field called fails. So now I end up with 2 new fields or new variables, one called successes and one called fails, that has a whole bunch of ones and zeros, whether it is a 200 or a 400. Then I'm going to sum up all those ones and zeros. So if I sum up all my successes, I now have a count of all my successes. And I do the exact same thing for my fails. I now have a count of all my fails. But notice, I'm doing it by time slice. Here's the cool thing, that now for each individual point in here, I have the count of successes and a count of fails because I did that count by time slice. As you would expect, then I create my failure rate by dividing my fail count by my success count. So I now have myself a nice failure rate, which we were identifying in here, remember? Failure rate, which was my fail count divided by my success count. So now I have these 3 fields. I can sort my information by my time slice so that it looks nice and organized. But then I use this operator, which is what I wanted to get to. The outlier operator allows me to not only get those numbers on these first 3 columns, but it builds all these other numbers for me, effectively identifying when my failure rate is out of the norm. So notice that I'm applying outlier on failure rate. Ignore these guys for now. These are all options for my outlier. But what I did is I applied outlier on failure rate, which allows me to create a graph like this. Now, what are these other fields in here? Window says, all right, in order for me to identify what the standard deviation is going to be at this point in time, how many points do I want to go backwards to find out what the standard deviation should be now? And in our case, we selected a window of 5. That means that for this data point, I had to go back 5 data points and figure out what the standard deviation should be for that data point. That is why you notice there's 5 data points missing here, because it had to wait 5 data points for it to have enough information to start showing you what a standard deviation should look like. This threshold is showing you how many standard deviations do you want to show. I could have said 2, and in which case I'm going to have a lot more violations because my threshold is now 2. Notice that? Consecutive means how many violations have to happen before I actually let you know. This says before I put a pink triangle there have to be 5 consecutive violations before I notify you. And direction just says, do you want me to tell you when there's a violation above, or do you want me to also tell you when there's a violation below the standard deviation? So that's the plus minus. And in this case, I probably have some below as well, as you can see here. All right, so this is great. This is all fantastic. Now I've been able to create what I call a dynamic threshold for my 404s. Instead of just looking at a count of my 404s and setting up an alert when that count goes above a certain number, what I'm doing is I'm looking at my 404s in relation to my 200s so that I can create what I call a failure rate and then identify an outlier on that particular failure rate. There seems to be a question on the PEC. Let me go to that question. The question is, why do you have to sum successes? So Stephen is asking, why do I have to sum successes in here? The reason, Stephen, that I have to sum successes is because if I was looking at only, say, 400s or only 200s, then I could easily just, I wouldn't have to even do this if statement. I could just straight up do a count. So actually, let me build a new one here just to show you with example what I mean. Let me just take that as a template. Let me take this here as a, oops, sorry. I meant to do this. Let me just copy this. So Stephen, if I just wanted to count one of them, for example, if I just wanted to count my 404s, where status code equals 404, I wouldn't even need a parentheses. I could literally just do this, count by time slice. And all of a sudden now I actually have a count of my 404s by time slice. So that's pretty easy and straightforward. However, in this particular case, I'm actually looking at 2, or you could be more, different types of status codes. Therefore, I have to create a new flag where I identify with that flag which one is which one is a 1, which one is a 200, which one is a 404, which one is a 500. And once I have this whole bunch of 1s and 0s, then I run a sum so that I can end up with a proper count of, by summing all the 1s, I end up with a proper count of my successes, and the same thing with a proper count of my fails. So I had to go through an extra step just to come up with a count for all those numbers. Okay. So the second question is successes an array? No, I think you're, again, for everybody on the call, Stephen is asking, is successes an array? And the answer is no. It's much, much simpler than that. Successes is simply as a matter of fact, let me do this. Let me comment out all these fields so that I can show you the intermediate step, and that's going to give you a good idea of what it actually is. If I run this query now, and I look at the results for that query, you will notice that that successes is literally just another field that either has a 1 or a 0 in it. And in this particular case, most of them seem to be 1s. Let me open this a little bit bigger. So here is my message still, and successes and fails, which I built, is just another field that looks at the status code. And if the status code matches 200 something, it sets this to 1, or and it sets this to 0, and vice versa. If this looks like a 400, it'll set this to 0 and this to 1. So it's much simpler than an array. It's literally just another field that we're creating with a whole bunch of 1s and 0s. And so to answer your first question again, if I do an aggregation of all my successes, that'll give me a count of how many 200s I have. And if I do a sum of all my fails, that'll give me a count of how many 400s I have. Does that make sense? Good. All right, super. I'm glad to, super. Yeah, keep the questions coming, guys, because this makes it a lot more interesting for me as well. All right, good deal. So Outlier is just a fantastic tool to identify where you've had things that are out of the norm. And what I want to show you is the last thing with Outlier. This makes a fantastic, fantastic example for an alert, because you notice all these pink triangles. If I wanted to alert for when those pink triangles happen, let me go back to the data itself. Whenever there's a pink triangle, there's a 1 here under failure rate violation. So all I have to do is say, where failure rate violation is greater than 0. And this is going to either show me data or not, depending on whether I have violations or not. So if this actually returns some values, that I know I actually do have some violations. So just to complete this, this is not an alerts webinar, but just to complete the story, I'm going to set up the webinar, set up the alert itself so you can see. I'm going to go to scheduled search and say, let's say that we wanted to run this on an hourly basis and that we want to run a time range of 60 minutes. And I want to send a notification anytime the number of results is greater than 0. And the reason why this will work is because we have this where clause. And if I have no violations, I'm going to get no results, and this thing is not going to trigger. But if I have violations, I'm going to have some results, and therefore I can email Mario at Sumo Logic, and I have myself an alert. All right, so I just wanted to complete that idea with the alert itself. Okay, that's Outlier. Hand in hand with the Outlier, I actually wanted to talk a little bit about Predict. This is a pretty cool one. Predict, let me run the query here first and show you in a graph what it does, and then we're going to go back and look at the numbers. What Predict does, and in reality, what I should have done is I should have gone in here and showed you the Predict operator so that you know how to fish instead of me just showing you the how to catch the fish. So here's Predict. It shows you the syntax itself. There's a few rules that you have to abide by. There's a few limitations, but I'm going to save you reading through all this and just show you through an example. So in this particular case, Predict is allowing me to look at data points in the present and predict what those numbers are going to look like in the future. And I can decide how much that future should be. Should I look 1 minute in the future, 5 minutes in the future, or what the case might be? In this particular case, I am looking at Apache Access hits or requests that I'm getting. I'm counting those requests by time slice, and then I'm just predicting how many more requests I'm going to be getting in the next 10 buckets. And in this particular case, a bucket happens to be 5 minutes. So I'm looking for the next 50 minutes worth of information of how that thing is going to look. There's a little more information that meets the eye that comes from here. Not only am I getting the actual data points along with a line that predicts what it should be, but I'm also, if I click here, I can see the absolute value that is the difference between the blue line and the light blue line. So if that light blue line were to dip under the blue line, then that's why we're looking at the absolute value of that request error. So this pink bars are showing me in size the difference between those two blue lines. And if you go back to the table itself, you could see the columns. I can see the time slice, I can see the requests, I can see the request predicted, and I can see the difference. That request errors is the difference between the request and the prediction itself. So of course, you can imagine that after a certain point, let me go to page 2, there is no more request error because there is no actual points. We just have a prediction for the last 10 data points, as you notice here, but there is no actual value, so there is no request for that. So, like I mentioned, Predict is just a great example to show you how things are going to look in the future. Another perfect use case, actually, I think this one is in the documentation, so I'm going to go there. The one here in the documentation is looking at items that are sitting in a queue, and I can see how I'm little by little taking care of those items in the queue. So if I want to predict when that queue is going to be empty, I can use this predict operator to show me around what time that queue is going to get to 0 according to this prediction. All right, super. No questions? Let me jump to the next one. Let's try this one, transaction operator. I think it's definitely a lot more advanced than the beginner ones that I started showing, but this one's going to make a great one. Let me just go find it here so I could talk a little bit about it through here. So transaction operator, it's going to allow you to connect those, let's just open this one here. Transaction operator is going to allow you to connect those transactions that have a common ID, or perhaps that you don't have an ID, but you can use a username, you can use an email, and in the case that I'm going to show you in my example, I'm just using an IP address. So it allows you to build a flow diagram that shows you messages that go from one state to another. Let me show you my example in here. Oops, it's in here. In my case, what I'm doing is I have some e-commerce data. I have a fake website called eCommerce, and I can see from the URL that is on my messages. Let me go back to the messages themselves and just show you. On the messages themselves, I can see things like order confirmed. I can see from the from the URL that people are on their checkout, under confirmation, or I can see when they're verifying a credit card. I can see the billing verification. So this is the kind of logs that I'm actually getting through my data. Well, what I'm going to do is I'm going to do a little bit of parsing of that data. The first thing that I do is I parse the IP address, because this is what I'm going to be using as a unique ID. Not ideal, but it works. If I had a user ID or if I had a transaction ID, it would be fantastic. But in this case, I'm using the IP address. So I parse that IP address, and then I'm going to say I want to use the operator transaction on the IP address that I just parsed over here, and I'm going to define some states. So look at that URL and find the word confirmation, and I want to define that at a state called confirmation. I'm going to do the same thing with ordered shipped, with cart, with shipping info, with billing info. There's many, many more states in my data, but I just chose to pull out 5 different states here. And then with that particular data, I'm going to say, I want to see those results by flow. Especially, I want to see them when it goes from one state to the next. So what that allows me to do is look at my aggregated data from one state to the next. In this case, it's going from the confirmation state to the order shipped state, and I have 6 of those. And this is just sample data. But the cool thing is I can easily put that in a flow diagram, and it's now showing me how most of my users came in. They looked at some item, they put it in the cart. Then they were looking at the shipping info to find out when they could get it. But unfortunately, not many people bought. Not many people went on to confirmation and shipping that order. So this gives me some good information to go back perhaps to my design team and tell them, maybe the button is confusing on my website and people are not knowing how to buy from us, or perhaps the pictures we have or the information we have about shipping is not that well thought out, and people are not understanding what kind of information is coming from there. To understand a little more of what you can get from this kind of stuff, let me comment out a few of these results, a few of these lines. And this is what I encourage you to do. Take a template and then start commenting out some fields so that you can see intermediate steps. And if I show you here, for example, I ran this same query without the results by flow, meaning I don't want them to aggregate by flow itself. And what I see is some start time by IP address. Remember that IP address is my unique ID. I can see the start time, I can see the end time of each, and then I can see which are the different states it moved from. It went from this state to this state. If I then uncomment the results by flow, I will see that now it's showing me by IP address from which state to which state it went, what's the latency, what's the end time, and in this case it's showing me in milliseconds, so I could configure this to show me something a little bit prettier, all the way to now I want it to count by state from state. All right, I'm running a little bit out of time, and I wanted to show you a few other operators, but I'm giving you the gist. I would highly encourage that you go into the documentation and read a little bit more about limitations on these or what other options are available for you. I want to show you one other one that is pretty cool. What about mapping those IP addresses? I showed you some stuff that showed a map and with a little dot showing me how many things are, how many hits I'm getting from different locations. This one's always a winner. People love it. In this particular case, I'm going against source category equals Apache access. I'm parsing out the IP address, so I'm storing it in a field called client IP, and I'm using the lookup operator. Lookup allows me to look for latitude and longitude and a few other fields like country code and region and zip code and all that good stuff. But in this case, I'm just looking for latitude and longitude, and I'm doing it from a service that we provide called GeoDefault, where the IP address is equal to the field that we just parsed, client IP. Now I do a count by latitude and longitude. If I run that query, let's say for the last 60 minutes, I'm going to get a list of all my latitudes and longitudes that is sorted by the count. So there you go. I have most hits coming from this latitude and longitude. And then we can just use a plugin for a Google map that allows us to grab all those numbers and drop them on a map itself. I could get a little fancier and say, perhaps I also want to get country code. How do I know which fields are available? You can go to the help and find out exactly which fields are available. So if I go by country code, let's look at that table again. You will see that now I have a field called country code. And what if I only wanted those in the US? Well, that's easy enough. I can put a where clause in here and say where country code equals, and I can specify US only. And now I don't even have to count by country code because it's only going to be country code US. I can run that. Now I've gotten only those that are by US, and if I map them, the map is smart enough to zoom in on the US and just show me those particular hits that are coming from the US. So I've given you now the secret of what's behind all those out-of-the-box apps and how they built those maps themselves. Okay, very good. I wanted to show you one last one only because I'm running out of time, but I unfortunately do not have data in my system to show you a live example. However, I did come up with a good one that is available, and I'm going to put this on the community very soon, and I'll show you community. I wanted to talk about join operator, and join operator works very, very similar to an outer join or to a join in SQL, in SQL. In this particular case, if you notice, I am looking for my source category prod API webhooks, and I'm looking only for those messages that have the keyword webhook worker. And then what I'm doing is from those messages, so I'm getting two types of messages. I'm getting a message with the ID itself that says I'm sending an HTTP request with these many bytes and the message body to this particular URL. And then I'm getting another type of message that says something like, for this ID, I had a failure, and this is the message failure that I got. So what I want to do is I want to be able to link those two messages. I want to know when the message was sent and what was the URL that it was sent to. And then when it failed, what was the message that came back? So what I can do is I can use the join operator. And the syntax of that join operator, again, I should just go here and show you that all this, by the way, exists in the documentation. So when you get a chance, by all means, go in there and read a little bit more information about this. But the syntax is join and then the parse statement on T1 and then a second parse statement on T2. You could have a third or fourth or fifth parse statement on T3, T4, T5. And then what am I linking on? In this case, on T1A equals T2C and T2A equals T3E, for example. I'm going to make it a little easier for you and just do, oops, where was it? It was here. In this case, I parse a statement that says info, and there's an ID that I want to extract out of that. And so I'm extracting ID, bytes, and URL, and I'm putting it into an array called info. And I'm also extracting ID and message, and I'm putting it into an array called failure. And then I can say on info.id, remember info.id versus failure.id. So I'm mapping on ID for each of the messages themselves. Now, what I wanted to point out is that if you want to use any of these fields later on, you actually have to use an underscore, not a dot. So if I only wanted to show the fields ID, URL, message, and message time, this is how I would say it. I want to say fields, info ID, so just display those messages. So you notice I've replaced the dot with an underscore. And if you want to do additional filtering, so again, I'm using this field, I can say where info URL equals insert webhook URL here. So this is just a great way for me to easily join messages by IDs by using the join operator itself. And just for kicks, I left a little example here on how to format message time into something that is a little more readable as well. All right, so I've covered quite a bit today, quite a bit of slightly more advanced queries rather than your basic ones. However, for those of you who are looking for additional queries or even basic or more advanced ones, I want to point you to the query library in our Sumo Dojo. And that query library, these are just some examples. What if I want to find things like status code trends over time or IP addresses by bandwidth uses? These are just some very simple examples that are out there, but I want to show you how to get to them. If you're in your environment, you go under help and you go to community, it's actually going to open our community called Sumo Dojo. And here you can knock yourself silly. You can start searching for things like Outlier, for example, and it should bring back a whole bunch of posts and answers that people have put out there about outliers. Look at this one. Here's one from a nice guy called Mario Sanchez about creating meaningful alerts. As a matter of fact, let me show you this one. And you probably will recognize this. Look at this, success failed, success count. So that thing that I showed you exists in here. How wonderful. But what I wanted to show you is, yes, you can search in here for anything that you want. But also what we've done for you is we've actually created a topic called Query Library. So if you go under Query Library, this is going to show you a whole bunch of queries that work as templates. Here's a customer from Kronos Global who put one of the templates that works really well for them. Here they put another one in here. But basically, these are just examples of queries that you can start using right off the bat. You copy to paste them. Perhaps you're going to have to change your source category to match your particular needs. You might have to change the parse statement because the queries, the syntax of the format of the log files is different. But there's tons and tons and tons of queries here that will certainly get you started, which you can search for by going to Query Library, or also just search straight up by going into the search string here. All right. With that said, let me just go back to this and let me put it out there for questions if there's any particular questions out there. While you're typing your questions, if you have any, let me just mention that if you need additional help, obviously search and documentation. I pointed you to documentation already. Let me point you to that training page as well. So if you haven't been to it, sumologic.com/training, there's a lot of self-serve information in here. In particular, that library that I was talking about. For those of you who are brand spanking new, I would highly suggest attending a quick start webinar, or either watching the webinar recorded or linking up for an upcoming webinar as well. If you have any questions, you can always post on Sumo Dojo. You can submit feature requests by going to help and say feature request. For example, if there's an app for something that doesn't exist, let's say Ruby on Rails, and you would want to see an app for that, let us know. Let us know and vote for it. The most people vote for it, the more it bubbles up, and we're going to take those. You can open a support case, or last but not least, if you need help for something very specific that you're not really sure if it's a support case or not, feel free to let us know. Customer success at sumologic.com, and we'd be more than happy to help out with that. All right. Any other questions from the audience?